Hello guys, so today I'll be talking about how lower bound and upper bound function works. Let me just generate a boilerplate code. Let's define an array. The elements are going to be 1, 5, 3, 7, 2. I'm taking 5 random elements. The size of this array is going to be size of ARR divided by size of, we can write here ARR 0 or we can just simply write here int. Okay, now for the lower bound and upper bound function to work in log n complexity, we have to sort the array first, else it will work in O of n complexity. So we can just write here sort ARR and sort ARR plus n. Okay, now the array is 1, 2, 3, 5 and then 7. Fine. Now let's define lower bound. What lower bound does is if the element is present in the array, then it will return an iterator. Now iterator in case of an vector, and it will be a pointer in case of an array. So it will return an iterator which will point to that particular element. What does this mean? So if in this array we are searching the lower bound of 2, so it will just return an iterator that will point to 2. Okay, now what if the element is not present? Else it will return an iterator which will point to next greater element. Okay, so let's suppose that we are trying to find the lower bound of 4. Now since 4 is not present in this array, so it will just return an iterator which will point to this 5. Okay, now for the upper bound, I'm going to code and execute as well. I'm just giving you a brief idea first. Okay, so how the upper bound function works is it whether the element is present or not, it will always return an iterator which will point to next greater element. So that means that whether the element is present or not. So let's suppose that we are trying to find the upper bound of 2. Now the element is present in the array, but still it is going to return an iterator or pointer which will point to this 3. Okay, so but if you remember, in case of an lower bound function, if we are trying to find the lower bound of 2, it will just return a pointer which will point to this 2 only. But upper bound, for upper bound, it doesn't matter whether the element is present or not. It will always return the pointer which will point to the next greater element. Okay, now for 4 as well, like if we try to find the upper bound of 4 which is not present in this array, so it will just return the pointer which will point to 5. Okay, let's execute the code now. Now first we have to define the pointer. So int star lb is equal to lower bound, give here the address and the element we are trying to find 3, and just I'm going to print this lb. Now since this lb is a pointer, so we are going to get some address first. Let me execute it. You see here we are getting some address. Okay, fine. Now since this is a pointer, we can just dereference it to get the element. Now after dereferencing, we are getting 3. Cool. So that means that lower bound of 3 in this array is 3 only. As I told you that if the element is present, then it will return an iterator which will point to that particular element. Now let's try to get lower bound of 4, the element which is not present. So in this case, it will return an iterator which will point to next greater element. So we can check it here. Okay, so we are getting 5. Fine. Okay, now let's check upper bound function. So I have to write here, let's find the upper bound of 2. If you can remember correctly, the lower bound of 2 was coming out to be 2. Or else I checked it for 3. I don't remember. But in case of a lower bound function, if the element is present, it is just going to return an iterator which will point to that particular element. But if I talk about this upper bound function, let me execute it. You see, we are getting 3 here. Even if the element 2 is present in this array, but still we are getting the next greater element. Okay. Okay. Now, if the element is not present, it will work just like the lower bound function. You see here, we are getting 5. Okay. For 4, we are getting 5. Okay, cool. Now, we can also get the index since this is just a pointer. So, subtracting this with the base address can give us the index as well. So, we were getting 5 before, now we are getting 3. 3 is the position of 5 if you can check here. So this is the 0 index, 1, 2 and 3. This is the third index as 0 based indexing. Okay, now okay, so this is how we get the position. Okay, let's check for vectors, like what modification do we need to do. So this will be vector of int arr, then size is fine. We have to write here arr dot begin and arr dot end, and this will be arr dot end. Then this will be again arr dot begin, here arr dot end, and here it will be arr dot begin. So now everything should work. Okay, no, sorry, this will be a o2. So now everything should still work the same, and yeah, we are still getting 3. Okay, now let me show you guys one cool use case of this lower bound and upper bound function. So this can be used to check the repetition of number. So let's suppose that my elements are 1, 5, 3, 5, 2, 7, 3, 3, 3, 3, and 3. Okay. Now after sorting, it is going to be 1, 2, how many times 3? 1, 2, 3, 4, 5, 1, 6. Okay. 5 and 7. Okay, 2 times 5 and then 7. Okay, now. So let's suppose that we have to check that how many times the 3 has been repeated. So this can be checked by the using the lower bound and upper bound function. So if I try to find the lower bound of 3 in this array, that is going to return me this pointer which will point to this index. Okay. Now if I'm trying to find the upper bound of 3, you know that even if the element is present, it is just going to return me the next greater element. So it will return a pointer which will point to this element. Now if I subtract these two, so where I'll get the number of repetition here. So let me just show you guys, then you will better understand it. Okay, so I have to write here lower bound of arr dot begin and I have to write here 3, and then it will be upper bound, and here upper bound of arr dot begin, and it's fine, and I have to write here cout frequency of 3 ub minus lb. Okay, so as you can check here, we are getting 6. So very easily we were able to find the frequency of 3. Okay, now there are other use cases as well. So it can be used in a multiple scenario, especially in the field of competitive programming. So yeah, this is it for this video, and you can also check out the C++ reference. I'll post this link in the description below. So yeah, thank you very much for watching this video. Thank you very much.